The chapter Work, Energy and Power is now complete, and again I am with a collection of questions that has already come in your JEE and Neet exams. So let's get started and be attentive. We are going to solve all the questions here. Let's start solving the questions. The first question is, a uniform cable of mass m and length L is placed on a horizontal surface such that its 1/nth part is hanging below the edge of the surface. To lift the hanging part of the cable up to the surface, the work done should be, we have to calculate the work done to lift the hanging part onto the surface. Let's first draw the situation. This is the part of chain which is on the surface, and this one is the hanging part. Now in question it is provided that 1/nth is hanging. So if we consider length of the whole chain to be L, then this part has to be equal to L/n, and the remaining part on the table will be equal to L minus L/n. Now mass of the cable is given m. So hanging part will be having mass that is equal to m/n. So if we write initial potential energy of the hanging part, that will be equal to, I am writing for the hanging part, it is equal to m/n, this is mass, into g into h. Now what is h? It has to be at the center of mass. So that will be equal to L/2n, which can be written as minus sign I have put because I am taking reference at this point, y to be 0 at this point. So it can be written as minus mg L upon 2n square. This is our equation number 1. Now when whole cable is on the table, then of its potential energy has to be 0, because that is I have taken as the reference level the horizontal surface itself. So at that surface potential energy will be 0. Now if we use work energy theorem, W can be written as delta U, that is equal to U final minus U initial. And if I substitute the values, it will come out to be minus of mgl upon 2n square, that is equal to mgl upon 2n square, which is our option number 4. The next question, a block of mass m is kept on a platform which starts from rest with constant acceleration g/2 upward. Work done by normal reaction on block in time t is. First let us calculate what is the normal reaction. Then as the forces acting are normal on this block, this is mg, so we can write n minus mg to be equal to ma. From here n is equal to mg plus ma. If I substitute the values, that is equal to mg plus a is given g/2, so it will be mg/2, and that is 3 mg/2. This is the normal reaction. Now in time t, what distance the block will move, that can be calculated by S can be written as ut plus half at square. It had started from rest, so u has to be 0. Directly we can write half at square. And value of acceleration is equal to g/2 in upward direction, then t square, that is g/4t square. So work done has to be equal to, as you can see, normal is also in upward direction, displacement is also in upward direction. So simply we have to multiply these two values, that will be equal to 3 mg/2 multiplied with g/4t square, that is equal to 3/8 mg square t square, which is our option number 2. In next question, I have force acting on a 2 kg object so that its position is given as a function of time. X is given as 3t square plus 5. What is the work done by this force in first 5 seconds, that we have to calculate? Okay, so velocity from here we can get, it has to be equal to dx/dt, that is 60 meter per second. Now work done we can write as, work done has to be equal to f dot dx. from initial position to final position. So it has to be between the positions x0 to x5. Now F we can write from here, it should be equal to m dv by dt, and dv by dt, as you can see, we got 60, so this can be written as 6, that is 6m. M is given 2 kg, so it will be equal to 12 Newton. So simply substitute the value here, that will be 12. Now dx will be equal to dx. Now we have to write x0 and x5. So let us first calculate it separately. x0 can be written as, this is the position at t is equal to 0, so it will be equal to 5, and x5 as 80. So we have to integrate this within limits 5 to 80. On integrating and substituting the values, we will get this 12 into 75, that is equal to 900 joule. Here we could have written work energy theorem as well, because we know that work has to be equal to change in kinetic energy. So that will be half mv final square minus half mv initial square, and on substituting the values we will get the same result, that is 900 joule, which is our option number 2. The next question is, when a rubber band is stretched by a distance x, it exerts a restoring force of magnitude ax plus bx square, where a and b are constants. The work done in stretching the unstretched rubber band by L is. Now in which way we should attempt this question? See, we know that change in potential energy of a system corresponding to a conservative internal force can be written as UF minus U initial, we can write as negative of work done by internal conservative force. So this should be equal to minus of F dot dr, where F is the internal conservative force, and this has to be within the limits initial to final. Now here F is given as ax plus bx square. So if we substitute these values here, W will be 0 to L ax plus bx square dx. If we integrate and substitute the limits, it will come out to be al square by 2 plus bl cube by 3. So this will be the amount of work done. Of course, here all the options are given positive, so it is interested only in its magnitude, its value. So the correct option is C. Now in next question, we have the situation, a point particle of mass m moves along the uniformly rough track PQR as shown in figure. The coefficient of friction between the particle and the rough track equals mu. The particle is released from rest from the point P and it comes to rest at a point R. The energies lost by the ball over the parts PQ and QR of the track are equal to each other. This is very important part, that energies lost over PQ and QR are equal, and no energy is lost when particle changes direction from PQ to QR. The values of coefficient of friction mu and distance x are respectively close to. We have to calculate value of mu and x. So let's start solving this numerical. As energy loss is same, so we can write mu mg cos theta for part PQ to be equal to mu mg QR, because QR is the flat part. From here we got QR to be equal to PQ cos theta, and if we substitute the values, it will be equal to 3.5 meter. This is the path on horizontal track. Now further we have to see what is decrease in potential energy. That should be equal to loss due to friction. So decrease in potential energy delta U, it should be equal to loss due to friction, and this decrease is having value mgh. So mgh can be written as equal to mu mg cos theta d1 plus mu mg, this one is for the flat part, d2. On substituting all the values, we will get 10m into 2 to be equal to mu into m into 10 into root 3 by 2 into 4 plus mu into m into 10 into 2 root 3. And on solving this, it will be 4 root 3 mu is equal to 2, which gives mu is equal to 1 by 2 root 3, that is 0.29. So let us now check the values. Mu we got as 0.29 and QR as 3.5 meter. This is our third option. Now the next question, a smooth wire of length 2 pi r is bent into a circle and kept in a vertical plane. A bead can slide smoothly on the wire. When the circle is rotating with angular speed omega, you can see it is shown here. About the vertical diameter AB, the bead is at rest with respect to the circular ring at position P as shown. Then value of omega square is equal to. Okay, so here the bead is at rest. Let us draw FBD for this bead, which is on a circular frame. So what forces will be there? Its weight mg. Normal has to be towards the center. Is there any other force? No. Then we have to write net force should be equal to centripetal force towards the center. Now we have to write for this bead, because it is moving in this horizontal circular path, for which this one is the radius of path, and towards the center it must be having some centripetal acceleration. So we can write for the bead n sin theta should be equal to, where this is angle theta with the vertical, n sin theta is equal to m omega square, and then this radius. Now what is this radius? It is given as r by 2. So this is equal to r by 2 here, which is the centripetal force required. One more equation we can write, since in horizontal direction it must be having some acceleration, in vertical direction it has to be at rest. So along vertical we can write n cos theta should be equal to mg. On solving these two equations, we will get tan theta to be equal to omega square r upon 2g. And then from geometry of figure, if I draw it here separately for the whole circle, this is r by 2, this is r, this angle is theta. So we can write from here tan theta is equal to r by 2 upon r square minus r square by 4, which will be equal to 1 by root 3. So here we got the value of tan theta to be 1 by root 3, which gives theta is equal to 30 degree. On substituting this value here, we will get omega square equal to 2g upon root 3r, and then which is our option number 2. In next question, a wire which passes through the hole in a small bead is bent in the form of quarter of a circle. The wire is fixed vertically on ground as shown. The bead is released from near the top of the wire and it slides along the wire without friction. As the bead moves from A to B, the force it applies on the wire is. Now we have to check what is the force applied on the wire as the bead is moving from A to B and in what direction it will be. So if we consider it at some intermediate position, let that be here, this length being h, which is at angle theta from the vertical, then this h can be written as r cos theta. In this direction mg will be acting and one normal has to be there along this direction. So we can write from conservation of energy mgr 1 minus cos theta is equal to half mv square. So radial force equation will give mg cos theta minus n to be equal to mv square by r. Now on solving these two equations, it will provide n to be equal to mg 3 cos theta minus 2. I have substituted the values here. Now when n is 0, then we will get cos theta to be equal to 2/3. So the normal force will act radially outward if cos theta is greater than 2/3 and will act inward if it is less than 2/3. And this is the force on ring, which should be opposite to this normal force. So the correct option is C. Now next question I have. A particle moves in one dimension from rest under the influence of a force that varies with distance travelled by the particle as shown in figure. Here I have a graph between source and distance. The kinetic energy of particle after it has travelled 3 meter is. So at this point we have to calculate kinetic energy of the particle. Now since this is graph between force and distance, so directly we can write work done has to be equal to area under the curve. So that should be equal to 2 into 2 plus 1/2 into 1 into 1 plus 2 into 1. This will be equal to 6.5 joule. It is the total work done, and as we know from work energy theorem, work done can be written as change in kinetic energy. So change in kinetic energy will be equal to 6.5 joule, and that has to be equal to the final kinetic energy because initial kinetic energy is 0. So our correct option is third option. Water is falling on the blades of turbine from height of 25 meter. 300 kg of water pours on the blade per minute. If the whole of energy is transferred to the turbine, power delivered is. We have to calculate the power, which can be written as energy per unit time, and since it is falling from some height, so this energy can be written as mgh upon time. Now if we substitute these values, it will be 300 into 9.8 into 25 upon time is per minute, so it has to be 60. On substituting all the values, it will come out to be 12250 watt, which is our option number 1. Next question. A ball of mass 2 kg and another of mass 4 kg are dropped together from a 60 feet tall building. After a fall of 30 feet each towards earth, the respective kinetic energy will be in the ratio of. Now here we have to calculate kinetic energy of these two balls. Now what it should be, that has to be equal to, from energy conservation we can write half mv square for first ball to be equal to mgh. Now as they are falling through the same height, so h has to be same for both, but their masses are different. For first particle, let's take that to be m1. Now for second particle, I am writing half m2v2 square, that to be equal to m2gh. If I take the ratios, this will be equal to kinetic energy of 1 upon kinetic energy of 2 is equal to m1 upon m2. These ratios are 2:4, that is 1:2, which is our option number C. Next question. If a long spring is stretched by 0.02 meter, its potential energy is U. If spring is stretched by 0.1 meter, then its potential energy will be. Now U can be written as half kx square. So half k, x is given 0.02, so it has to be square of 0.02. For next part, when it is stretched by 0.1 meter, let potential energy is U dashed. So then it can be written as half k into 0.1 square. Now if I divide these two, U dash upon U can be written as 0.1 into 0.1 upon 0.02 into 0.02. That will be equal to 100 upon 4, which is 25. So the correct option is U dash will be equal to 25 times U, which is our last option. The next question. The potential energy of a certain spring when stretched through a distance s is 10 joule. The amount of work that must be done on this spring to stretch it through an additional distance s will be. This is similar to the previous one. We can write 10 to be equal to half k. This x has to be this time equal to s. So this is half k s square. Now it is asking what amount of work must be done on this spring to stretch it through additional distance s. So if the total energy will be equal to, let that be u, it has to be equal to half k. Now the total stretch is 2s. So it has to be equal to 4s square. Now as we know that half ks square is equal to 10. So this is 4 times half ks square, that will be equal to 40 joule. But it is asking for amount of work for this additional distance. So that required work will be equal to 40 joule minus the initial work, that is 10 joule, and this will be 30 joule, which is our option number 1. Let us consider one example more. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has a constant magnitude p0. The instantaneous velocity of this car is proportional to. Different options are given here. So let us see how to solve this given problem. Power, as we know, can be written as equal to F into V, which is having value P0 that is provided in the question. Now we can write F as m dV by dt. So F is equal to m dV by dt to be multiplied with V, that will be equal to P0. On integrating both the sides, let us first take all the variables on one side. It is V dV on one side and dt on other side. Now integrate both the sides. We will get P0 t to be equal to mv square by 2. And from here we can write v square is equal to 2 P0 upon m into t. So v from this expression we can write as is proportional to t to the power 1 by 2, which is our correct option, that is option number B. The next question is, a particle of mass m is driven by a machine that delivers a constant power k watts. Here power is given constant. If the particle starts from rest, the force on the particle at time t is. See, here about power it is given that power is constant, and then it is asking for force. So we have to write relation between power and force, and I think you can now recall the relation, what it should be. Power can be written as F multiplied with V. F can be written as m dV by dt as well, multiplied with V. Now if we take dt on other side, it will be P dt is equal to m v dv. Now integrate both sides. Power I have written outside because it is constant and its value is given k. So this will be kt is equal to m v square by 2. From here we got value of v to be 2 kt upon m under root. This is value of v, and we have to calculate force. So for force, first acceleration is needed, that is dv by dt. Differentiate the expression we got from here, that is root under 2 kt upon m, which will give, see, root under 2k by m is a constant, let us write it outside. Then this is only root t, which is to be differentiated. So that will be equal to 1 by 2 root t. Now on solving, it will be k upon 2mt under root. This is value of acceleration. So now we can write force to be equal to m multiplied with this. So it is m under root k upon 2mt, which on further solving will give mk upon 2t. Which option is this? This is our option number 1. I hope you understood and enjoyed the session, and now you are able to solve questions based on work, energy and power. So let's see further for the next session, where we have to start a new chapter, which is center of mass and rotation. Till then, goodbye.